right, let's start going over. Okay, so starting with 33. See, you guys even skipped the first three problems. You knew how to do them. So we have the log of x plus 7 minus log of 3 equals log of 7x plus 1. Alright, so you can expect all this stuff. There's going to be something like it on your final. That's why we're taking all the time to go through it. When I have a problem with multiple logs in it, we start out by combining any logs that we can. On the left, I have two logs being subtracted. How do you put those together? Divide. So you put the log once, and then you put x plus 7 divided by 3. Okay, now once you have a log on each side, what can you do?
You can drop the log.
Yep, those are going to go away. So we just have x plus 7 over 3 equals 7x plus 1. So to get x by itself, first let's get rid of our fraction. So we're going to multiply by 3 on both sides. I need to subtract my x. I think this was an actual quiz question one time, and I only remember it because right here, like a third of the class put x equals 5.
Yeah. Well, I do that all the time. Like I keep seeing this problem over and over, and I just keep putting x equals 5.
I should have just flipped the side because it's less confusing.
So we get 4 over 20 or 1/5. I do want to warn you on these log problems, you need to check your answers at the end, because remember the argument has to be positive when you plug it back in. So if I put in a 1/5 on all those, I'm good. But let's say you're on your final and you solve this and you maybe get x equals 0, x equals -2. Okay, if you put in a 0, 0 plus 7 is fine, 3 is fine, 1 is fine. But if you put in a -2, you've got 5, 3, -13. So does that work? No. So, hint, hint, I'm telling you this for a reason. Check your answers. There might be something on the final that, when you plug it back in, gives you a negative. So make sure you're verifying that your answers are okay. And of course, if both of them gave you a negative, what would your answer be? No solution. Okay. 34. Oh, I think this was like on the same quiz. Same two questions. Okay, can I take the 0.3 times my 4? No. Order of operations, you have to do exponents before you multiply. So I can't multiply those, but what I could do is divide by my 0.3. So I get 4 to the 0.2x equals 0.2 over 0.3, or that's equivalent to 2/3. Okay, we always check to see if we can get a common base. Like on problem 31, you were able to say 4 was equal to 2 to the second and just set your exponents equal. Can I get a common base here? So what do we do?
You can add logs.
And how does that help me?
You can take the 0.2x out in front of the log.
Properties of logs, those exponents come down. So now you have x times all this stuff. So to get x by itself, we just divide by everything we don't want. So I'm dividing by the 0.2 and the log 4. Do be careful when you put this in your calculator. Every time you push a log button, it opens a parenthesis, so you have to close it. You also need a second set around your entire denominator because there's more than one thing on that. And so we get -1.4624. with everybody? Number 35. Okay, I want you to graph this log. So it's y equals log base 4 of x. So in order to graph a log, we always change it to an exponential. Remember, you start with the base, you go across the equal sign. So this means 4 to the y power equals x. If you make a t-chart, are you plugging in numbers for x or for y? For y. It's the exponent. So you put in the -1, 0, and 1, just like when you graph an exponential. 4 to the -1 would be a 1/4. 4 to the 0 is 1, and 4 to the first is 4. So if I plot 1/4, -1, 1, 0, and 4, 1. And remember, these have a vertical asymptote at 0, so it just looks like that. Domain, as you go from left to right, this graph starts at 0, never touches it, so parentheses 0, comma infinity. The range is talking about your y. This end's going down forever, this one goes up forever.
How do we know that it doesn't touch 0?
If you think about this, will you ever do 4 to a power and get 0 for an answer? So you can't, if you take a positive number to a power, you only get positive answers out. So we'll never get the 0.
Thank you.
You're welcome. Any other questions there?
So that's why it doesn't have a bracket.
Mm-hmm. All right. 36, solving a system. So your final is 2 parts. There is a multiple choice and a short answer part. Multiple choice does not mean like 1-point questions, so just circle. They're still worth points. There are some that specifically say if you don't show work, you can't get any credit for. The others, they're worth a minimum of 3 points each. So would it be wise just to circle an answer? No, you still have to show me work. Since we never took a test over chapter 5, you can expect some of this chapter 5 stuff to be in the short answer section, the questions that are worth a few more points. So we'll have some systems like this. We did like 36, 37, 43, 38. All of that was from this last unit that we didn't take a test over. So you can probably expect to see several of those in the short answer section, which will be worth a few more points. So just kind of a warning there. All right. We have to take 2 of these at a time. And we have lots of options on how to do it. Basically, we want to take 2 at a time and eliminate a variable. I know this equation doesn't have a z, so I could choose to eliminate the z in one of them. Or if you look, the last equation already doesn't have a y, so I might want to eliminate y in the first one. So it really doesn't matter. I think that's what I'm going to do. I'm going to start with my first 2, and I'm going to eliminate y. If I'm going to add these, do I need to multiply by anything first to make my y's cancel?
No.
All right. Even easier. So 5x plus x will give me a 6x. Those y's drop. Got a minus z equals 5. So now I'm going to take these 2 equations. Neither one of those has a y, so I'm going to put them together and eliminate another variable. What do you want to eliminate? Z. So what do I need to do?
Multiply by -6 on the bottom.
So that gives me negative 18x plus 3z equals negative 15. So negative 18 and positive 2 is negative 16x. These cancel. Equals a negative 13. So then we divide definitely not going to work out to be nice and pretty, is it? Divide by negative 16, and x is 13 over 16. So we need x, y, z. I've got my x. Working backwards, I'm going to plug that in to find my y and z. So let's say I plugged it in here. So 6 times x, which was 13 over 16, minus z equals 5. What does that give me? 39 over 8. Is that right? You guys checking me? Minus z equals 5. If I subtract over my 39 over 8, get a negative 1/8. Divide by the negative, so z is positive 1/8.
So when you do that, do you always put it into the equation? Like you don't put it into one of the original ones?
You can go to the original. We should get the same answer. Hold on, I have a mistake, don't I? This should be a positive 1/8 right there, and then a negative 1/8 on my final answer. Okay, so now I have x and z, we just need y, so pick one of your equations. I'm just going to go with the x plus y equals 5. So my x was 13 over 16, plus y equals 5. 67 over 16, is that right? Okay. And then you just write it as an ordered triplet. Is that one okay? So 37 we were okay with. It's another system.
No, can we do 37?
You need to do it?
Yeah, I did something wrong there.
Okay. So we need to start out eliminating one of these variables, either the x squared or the y squared. What do you want to do? Okay, so I'm going to take the bottom one times 2. So I get 20x squared, 2y squared equals 100. If I add those together, I get 25x squared equals 125. If you divide by 25, you get 5. And then to get the x by itself, the opposite of a square is, and when you add a square root, you need, so x is plus and minus radical 5. Okay, now we have to find the y. So if x is radical 5, I'm going to put it into the second one. Radical 5 squared is 5, times 10 is 50. Subtract over my 50, so y squared equals 0. When you square root, you just get 0. So I have radical 5, 0. What happens if you plug in a negative radical 5? You get the same thing, don't you? Because you end up squaring, which makes it positive. So for the sake of time, I'm not going to write that all out. But when you put in negative 5, you also get the 0. Yeah.
So whenever I got my first one, I changed the radical 5 to a decimal, which is 2.24, and then I plugged that in for x. And I ended up getting, I still got 0 for y, but I got 25 somehow on both sides. Wait, actually, is Did you put yours in with the first equation?
Yeah.
Okay, I think I put mine.
Yeah, so if you
Okay.
put in yeah, because your 25's cancel. So you just plugged in the different
Okay.
equation. Okay. Sound alright? 38. So you'll probably have a nice multiplication problem on your final. Okay, first you have to make sure you can multiply it. What's the size of the first one?
2.
And the second one? So these 2's match. That means I can multiply them, and my final answer will be
2.
okay, so we're going to have 2 rows and 3 columns. So you're getting a total of 6 numbers. Okay? So to do this, you take a row times a column. So this is the number in row 1, column 1. So I'm going to take row 1, and I'm going to multiply that with column 1. Okay, so 5 times 3 is 15. 5 times 2 is 10. Add those and you get a 25. Moving down the row. This is row 1, column 2. So you're going to take row 1 times column 2. So 5 times -5 is -25. 5 times 6 is 30. -25 plus 30 is +5. Row 1, column 3. So row 1 times column 3. So 5 times 5 is 5. Sorry, 5 times 1 is 5. And 5 times 1 is 5. 5 plus 5 is 10. Now, we're going to move on to row 2. Row 2, column 1. So -6 times 3 is -18. 4 times 2 is 8. We get -10. Second row, -6 times -5 is +30. 4 times 6 is 24. Multiply those, 54. Last one, -6 times 1 is -6. 4 times 1 is 4. And we get -2. Any questions on that? On 39. So, inequalities. 39 and 42 are both looking at these inequalities. First thing we're going to do is treat it like it was an equal to. So if this were an equal sign, we would bring everything over and factor. So that's exactly where we're going to start. Subtract over your 5x. And then we factor. So multiply to 4, add to -5. Be -1 and -4. If you set each of those equal to 0, you get a +1 and +4. So then what I told you is think about a graph. This was a quadratic. Does it open up or down? Okay. Alright, so we wanted greater than 0. That means positives, above the axis. So if I look at this graph, it's above the axis over here and over there. It didn't say equal to, so no brackets. It's -infinity to 1, union 4 to infinity. Yes?
Why is it positive 1 and 4? Because x equals
If you
positive 1 plus that equals
Mm-hmm.
Okay.
Other questions here? $40. Alright, this one. I don't have any x squareds in here. I don't have any x's on the denominator. This is actually just linear. It's just like solving a linear equation. You could rewrite it to make that a little more obvious. X over 7 is the same as 1/7 x minus 3. Okay, when I have x minus 4 all over 3. If you separate that, that would be like a 1/3 x minus a 4/3. We got our plus. So, combine like terms. Negative 4/3 and positive 1 is a negative 1/3. If I want to get my x's on the same side, if I subtract over the 1/3 x, so 1/7 minus 1/3 would be negative 4 over 21. Add my 3. So negative 1/3 plus 3 would be 8/3. Then what do you do to get x by itself? Since the reciprocal is negative, what happens? Okay. So I get x is less than negative 14. Finally, I would like for you to write that as an interval. So less than negative 14 would be parentheses negative infinity to negative 14. It didn't have an equal to, so just a parenthesis, no bracket. Is that one okay? 42. Okay. This is an inequality involving a fraction. So our strategy here. If we had multiple terms, we had to condense everything into a single fraction, which thankfully we can skip right to that step here. It's already a single fraction. Then I had you figure out what made the top and bottom 0. So that would be a 4/3 and a negative 5. Put them on your number line, small to large, so negative 5 on the left. And let's graph this thing. When you graph it, do parentheses around top and bottom. And then if you look at your graph, we're checking to see if it's positive or negative. So, looking at this, you see that first little section is up here in the corner. So it's above the axis, so that was positive. Then my graph dipped down below the x-axis, so that's negative. and then it comes back above the x-axis, so it's positive again. I asked for less than 0. So less than would be negative. Equal to would mean bracket. However, I can't put a bracket on both of those. Why? Right. On a fraction, can the bottom ever equal 0? No. So that -5 has to have a parenthesis because it makes the bottom 0. But the 4/3 gets a bracket. Anything else from this section that you want to go over? So you guys want me to just do some review over things I think we need? Okay. Okay, so you guys are okay with multiplying matrices? We're good with that, the systems. Yesterday we did one of the rational equation problems, and I know there were some questions about asymptote rules. So let's run through another one of those. Would that be okay? There are a lot of points in those types of problems, so I think it wouldn't hurt to go over it. Let's say I gave you this problem. Okay, the first thing I would tell you, and I will break it down and tell you step by step, I want you to factor the numerator and denominator. So the top we can't factor. What would the bottom break into? Okay. And then I would ask you about your intercepts. Your x-intercept and your y-intercept. And x-intercept is when y equals 0. Wait. If I set my y, that's like my whole function, equal to 0. What would you do first to get rid of the fraction? You'd multiply over your denominator, wouldn't you? What's 0 times anything? So I get 0 equals 3x squared. Divide by 3. So 0 equals x squared, so what's x? 0. So on my graph, my x-intercept, we hit the x-axis at 0. Y-intercept is when x equals 0, so if you plug in 0 for all of your x's, what do you get? Three times 0 is 0. -4 times 3 is -12. 0 divided by -12 is 0. So my y-intercept is also 0. Okay, then I'll ask you about your asymptotes, vertical asymptotes. Those are x equals whatever makes the bottom 0. So what would make the bottom 0? So I'm going to plot those. They go on as dashed lines. But then we have to decide if it's horizontal or oblique. So remember those rules. If the degree on top is smaller, it's horizontal, y equals 0. If it's the same degree on top and bottom, you divide the leading coefficients. If the top is one more, it is oblique. Do you guys remember these? They really all have to do with long division. If I won't confuse you, I'll kind of explain why they are. If I gave you like x over x cubed plus 1, Okay, you just follow those rules. The degree on top is smaller than the bottom, so it should be y equals 0. If you were to do long division, when you go to divide those, when you do x divided by x cubed, do you get a whole number? X over x cubed, you have more x's on the bottom, right? It doesn't work out nicely. So you have 0. It doesn't go in evenly at all. If it were like 3x squared over x squared plus 1. Our rule says those are the same degree. If you divide 3 over 1, you get 3. If we set up the long division, okay, the 3x squared goes on the inside, x squared plus 1 goes on the outside. What's 3x squared divided by x squared? 3. And everything after that would be the remainder, which we ignore. When the top is 1 bigger, that's when we're able to do the long division. Okay, 3x cubed divided by x squared is 3x. And if you multiply, you get 3x cubed plus 3x squared plus 3x. Change your signs. Negative 3x squared divided by x squared is negative 3. And you get your oblique. So it all has to do with that long division. If you just want to memorize the rules, if the degree on top is smaller, then it's y equals 0. Same degree, you divide the leading coefficients. Top degree 1 bigger, that's when it's oblique, you do the long division. Okay. So make sure you know those rules. There'll be several questions involving those asymptotes. If I look at this one, my problem, we had a 3x squared over x squared. So it's the same degree on top and bottom. So that means it would be a horizontal asymptote. Y equals, you divide the leading coefficients. So 3 divided by 1 is 3. Okay, then how do you get your graph? Yep, use your calculator, and I believe it comes out to be something like this. So review those asymptote rules. Those, a question like that is worth probably at least 10 points because there's a lot of steps there. So make sure you understand how to do all those. We did have that on our study guide. Let's see, what else? Trying to look at my list to make sure we've gone over everything. We did some of the long division yesterday, so you guys are okay with that? For the oblique, when you had to divide it. Let's do a word problem. We did an interest one on the study guide. Let's do something different this time. Let's say Let's see. Alright. Here's our problem for me just making up something off the top of my head, so we'll see how well it works out. One car is traveling 20 miles per hour faster than the other. They leave school at the same time, heading opposite directions. After 3 hours, they are 300 miles apart. How fast is the faster car going? So I'm talking about distance here. What should I do with those? Or how should I start by organizing my information? What formula goes across the top? Okay. Alright, so I've got my two cars here. We need car 1 and car 2. We'll see if we have a total. I don't really know. So how fast is the first car going? One is going 20 miles per hour faster than the other. Yeah, so one of these has to be x, and one has to be x plus 20. How long are we driving? So my time is 3. After 3 hours, they are 300 miles apart. Where does that go? Yeah, that's our total distance. Okay, so then we use our formula, rate times time, so x times 3 is 3x. 3 times x plus 20. How do we set up our equation?
Add the first two to equal the greater
Okay. So if I distribute, so when I solve this, I get x equals 40. Is that my final answer? I wanted to know how fast the faster car was going. So if this one's going 40, the faster one is going 60. Okay. Is that one all right? What about what do we have to do to add or subtract fractions?
Get the same denominator.
We need a common denominator. So the first one has x plus 2. What does it need to look like the second one?
And x plus 4.
So I'm going to multiply top and bottom by x plus 4. Second one has x plus 4, so it needs
X plus minus 2.
multiply top and bottom by x minus 2. Alright, so if I distribute the top, we get x squared plus 4x over x minus 2, x plus 4. Minus this one, if we distribute, we get 3x squared minus 6x over x minus 2, x plus 4. What should I do about this minus?
Distribute.
Now the denominators are the same, so we can make one big fraction. X squared and negative 3x squared is negative 2x squared. 4x plus 6x is a 10x. So to add or subtract fractions, we need a common denominator. If I gave you that's a problem. Do we need a common denominator to divide? No. What is the rule for dividing fractions? What do we have to do?
Multiply and flip the second.
Good. So the first one stays the same. Change this to times and flip the second. Okay, I know the bell's going to ring on me soon. What do I need to do now?
Factor.
Yeah, so for the sake of time, I'm just going to quickly factor these for you. So you factor every single piece, and then what do?
Cancel.
Cancel things that show up on top and bottom. So after I factor them, I can drop an x plus 7, an x plus 2, even that x minus 2. We're just left with x plus 10 over x plus 5. So tomorrow, bring your books, your study guide, and if you're a fast test taker, bring something else to work on.